Every time you talk to an AI chatbot, it forgets your name the millisecond its response finishes typing. It has no memory bank, no recall, and absolutely no concept of who you are. The machine is essentially a digital goldfish. Yet, it manages to maintain a flawless illusion of continuous conversation. How this trick works is a masterpiece of software engineering, but a brand new security discovery reveals it has left your most private chats exposed to background web trackers. For decades, using the internet was a series of cold, transactional clicks. You typed a query into a search engine, got a list of blue links, and left. But today, millions of us use AI chatbots as continuous partners. We ask them to debug our code, draft our emails, and even act as sounding boards for our personal problems. Researchers have documented a striking psychological phenomenon here. Because these systems mimic the polite, empathetic flow of human conversation, our brains are hardwired to assume there is a continuous mind on the other side. We naturally project a biography onto the machine, believing it remembers our last conversation just like a human colleague would. But beneath the polite pleasantries, the system is fundamentally blank. To understand why chatbots do not actually remember you, you have to understand a concept called statelessness. Imagine you are in an interrogation room. You are talking to a detective who has severe amnesia. Every single time he steps out of the room to grab a cup of coffee, his mind is completely wiped. When he walks back in, he has absolutely no idea who you are, what you are doing there, or what you just said 2 minutes ago. For him, the universe begins anew every time the door clicks shut. This is exactly how large language models work. They are stateless. Every time you send a new message, the model does not access a stored memory of your previous chat. It processes your input as if it is meeting you for the very first time in its life. So how does the detective in our interrogation room know what you just said? Simple. Every time he walks back into the room, you have to hand him a complete, printed transcript of everything you have both said since the interrogation started. In the world of AI, this is called token-refeeding. When you type your fourth message in a chat, the user interface secretly grabs message 1, message 2, and message 3, glues them to your new message, and sends the entire giant package to the server. The AI reads this massive block of text from scratch, computes the next logical word, and delivers the answer. You think you are having a continuous conversation, but you are actually just resubmitting an ever-growing book of your past conversation history with every single click. But this transcript stuffing trick has a hard physical limit. It is called the context window. Every model can only read a certain number of words at a time. If your transcript gets too long, the system simply cannot fit it all in. When this happens, the chatbot faces a critical choice. It either has to drop the oldest parts of your conversation entirely or try to summarize them. This is where academic studies show the illusion begins to shatter. As your conversation goes on, the chatbot experiences context drift. It starts forgetting crucial details you mentioned 10 minutes ago, slips back into default personalities, or begins to hallucinate entirely new facts to fill the gaps in its artificial memory. The goldfish is running out of space. To stretch this limited memory, engineers developed a system called Retrieval-Augmented Generation, or RAG. Think of it as a hyper-efficient librarian standing next to our forgetful detective. Instead of handing the detective a 1,000-page transcript of your entire history across several months, the librarian uses vector math to index your past chats. When you ask a question, the librarian instantly scans your archive, pulls out only the 3 most relevant paragraphs from last week, and hands just those snippets to the detective. This allows the AI to pretend it remembers something you said a month ago. But this engineering compromise has created a massive, hidden side effect. To organize and retrieve your past chats, the system has to generate highly specific tracking labels. To keep your chat history organized across your phone, your laptop, and different sessions, the AI platform must generate unique chat identifiers, session tokens, and automated summary titles. In April 2026, a groundbreaking security study examined 20 popular AI chatbots to see how this conversation metadata behaves. What they discovered is alarming. Because these platforms rely on third-party web trackers and advertising networks for analytics, they are silently leaking this highly sensitive metadata. When the system creates a chat title based on your prompt or assigns a unique ID to your session, Those identifiers are routinely transmitted across the web in background network traffic. Even if your actual chat text remains encrypted, background trackers can now link your unique conversational identity across the websites you visit. The illusion of AI memory is incredibly convincing because we want to believe in it. We want to feel like we are talking to a tool that understands us, grows with us, and remembers our preferences. But the reality is a cold, mechanical cycle of packaging, shipping, and resubmitting our entire data history with every single prompt. To make that cycle work, tech companies have built a massive scaffolding of tracking tags and identifiers. In our search for a machine that remembers, we have built a system that ensures the web never forgets. The next time you type a personal question into a chat box, remember the detective in the room. He is not remembering you. He is just reading the file you handed him, while the rest of the world watches over his shoulder.